Hello, we're going to look this week mainly at metals. If when we go through the periodic table, we'll notice here that most of the elements are in fact metals. So all of this column are metals, we call these the alkali metals. All of this column are metals, we call them the earth alkali metals. Some people say it as alkaline earth metals. This whole middle area here, including these down the bottom, are what we call the transition metals. And then there's this area here that behaves a bit like metals, this kind of whole area here. These are all the metals, and you'll see that most of the periodic table consists of metals. Metals, when they form compounds, have loose electrons around the edge of the atoms, and they will tend to form compounds by donating electrons. So lithium will donate an electron, as will sodium, as will calcium, as will rubidium, as will cesium, as will francium. Beryllium, on the other hand, will donate 2 electrons, as will magnesium, as will calcium, as will strontium, as will barium, as will radium. The elements in the periodic table that are in the middle, the transition metals, they tend to donate a couple of electrons, but because they've also got gaps that are not on the very outside of the atom, but a little bit closer into the middle of the atom, they can actually sometimes donate more than 2 or less than 2. For example, copper can donate 1 or 2, nickel can donate 2 or 4, iron can do 2 or 3, manganese can do 2, 4, 6 or 7, and chromium can do 2, 3 and 6. So there's quite a few interesting elements down here in these transition metals. When we get to this column donate 3 electrons. There's an area of elements that are kind of halfway between the two, and we call these elements the metalloids, and they're kind of half metal, half non-metal. And then there's the elements on this side of the periodic table that are the non-metals. There are not that many non-metals, and non-metals are the opposite. They tend to, when they form compounds, grab electrons off the metals, or they may even grab electrons off other non-metals and share them between them. So non-metals grab electrons, metals donate electrons. And then there's the final group, the noble gases, that don't do anything much and don't normally ever form a compound. That's basically what we're looking at this week. As far as the properties of metals go, metals tend to conduct electricity well and conduct heat well, and that's because they've got these loose electrons on the edge of the atoms, whereas non-metals are the opposite. They tend to conduct heat and electricity poorly because they hold their electrons in and don't let them freely wander about. We also have metals being fairly strong. Metals can be pulled out into wires. We call that process of pulling them out making them ductile, and metals can also be beaten into different shapes, like you've seen that in sheet metal and things like that, and we call that process malleability, or we say the metals are malleable. Metals can often be shiny, and you can often make mirrors out of metals. Non-metals tend to be the opposite. They tend to be weak, powdery, not strong, and some of them, for example, nitrogen, oxygen, fluorine and chlorine at room temperature are actually gases. So they're the basic differences. Metalloids are halfway between the two, and the metalloids tend to normally behave like non-metals, but they can occasionally behave like metals. So for instance, there are certain non-metalloids in certain situations can conduct electricity. Metalloids have been really useful for making computers and electronics, because by having something that sometimes conducts electricity and sometimes doesn't, you can have something that sometimes is on and sometimes is off, and therefore it can make a decision, and that's basically the principle of computing. So metalloids are very important for computing, and things like silicon, for instance, is a very, very important element that is found in lots of computer chips, because it can both conduct and do the opposite and not conduct, so it can make decisions. Okay, that's basically what we're having a look at this week, explained simply. Thank you.